Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Hari ini saya nak explain tentang charge in a uniform electric field under topic electrostatics. So our learning outcome for today are explain quantitatively with the aid of a diagram the motion of charge in a uniform electric field, which is stationary charge, case yang pertama, charge moving perpendicularly to the field, case yang kedua, charge moving parallel to the field, case yang ketiga, and the fourth one, charge in dynamic equilibrium. And then the next learning outcome, to use equation E equals to change of electric potential divided by D for uniform electric field. Okay, first we need to know what is meant by uniform electric field. Okay, uniform electric field is described as the electric field lines which is moving in a straight line and then parallel to each other and equally spaced. As you can see in my video or animation, this animation, the lines is equally spaced. For the next slide, is about the magnitude of the uniform electric field. If we need to calculate the electric field, the magnitude can be calculated by using formula change of electric potential or electric potential between the plates divided by the distance between them. As in this example, we do have positive plate, positive 15 volt, and then the negative plate is negative 10 volt, separated by a distance 2 centimeter. So our change of delta V will be equals to 15 minus with negative 10 divided by 2 centimeter, which is equal to 0.02. So the change of the electric potential will be 25 divided by 0.02. Before this, I talked to you that we do have 4 cases for moving charge in a uniform electric field. The first case is about stationary charge, okay, charge yang tidak bergerak dalam uniform electric field. Okay, we do have a parallel plate as in animation. The direction of the electric field are moving from positive plate towards to the negative plate, and then we do have a negative charge such as an electron. The electron is firstly at the stationary state, and then because of the electrostatic force, it is going into the positive plate. So the electric force exerted on the charge, we do have electrostatic force equals to Q multiplied with E. Q is the magnitude of charge multiplied with the electric field strength for this region. And then electric force contributes the net force and cause the particle to accelerate. So we do have electrostatic force equals to MA, means the equation of the QE will be equals to the mass of the charge multiplied with the acceleration of the particle. Case number 2, for the charge moving perpendicularly to the field. We do have parallel plate again. This animation is showing the electron is moving upward direction, which is towards to the positive plate, but the path is a little bit parabolic. So the charge will be deflected and move under influence of the electric force as well as before. For this case, I write a diagram in the illustration. The initial velocity will be deflected to the final velocity along the parallel plate. Okay, and then it's going upward because it attracts to the positive plate. Okay, the negative charge attract to the positive plate. So the difference in the vertical direction from top to the initial point, which is SY, and then the distance along the plate, we call it as SX. So as you can see here, to find the value of the acceleration, okay, before this we thought that QE equals to MA. The acceleration can be found by using kinematics equation because it is parabolic path. So we need to recall chapter 2 in semester 1. For the third case, charge moving parallel to the field. Okay, in here we do have 2 types. The first one in this animation, it's showing that we do have a negative charge, which is moving upward. So the direction of the force, electrostatic force, is upward as well because the negative charge is attract to the positive plate. So here in this case, the charge accelerates along a straight line. But if we do have a negative charge, which is we need it to going to the downward direction, which is opposite direction of the electrostatic force, means that the charge decelerate along a straight line. Okay, so we do have two types, either accelerate or decelerate. In this case, which is charge moving parallel to the field. The last case, which is charge in dynamic equilibrium, means that the charge move with constant velocity. Okay, velocity dia malah. Means also the particle weight is at the opposite direction to the electric force. When it is balanced, okay, the force upward and downward is balanced, means that the particle are moving in a straight line along the uniform electric field. So here we know that every particle that has a mass, so we do have a weight, which is the weight direction is actually acting downward towards the direction of the acceleration due to gravity. So here we do have direction of the weight downward, and then the direction of the force upward will be the direction of the electrostatic force. And then in this case, the charge will be not deflected by the field. So that's it for today.